Why is the universe we see not the real universe? Let's assume that when you travel on a ship at the speed of light, when the spacecraft heads to interstellar space, we will see the beautiful Milky Way, and 2.3 million light-years away, the outer Andromeda Galaxy is among us. The surrounding universe looks almost completely empty and silent, but this is not the case, according to Einstein. Let's be frank when speaking about the concept of space and time in the theory of relativity. The universe is composed of time and space, and a huge geometric structure composed of multiple powers surrounds us all the time. Without the influence of any gravitational force, when we throw a small ball, it will go forward in a straight line forever. But the problem is that this huge space-time grid structure does not, according to the general theory of relativity, it stays completely stationary. However, anything with mass is not completely stationary. Massive objects can bend space-time around them. Our universe is filled with geometries that distort four-dimensional space-time. What structure of celestial body is there, you ask? Well, when we turn our attention to galaxies, when you look at a galaxy, you can see the space-time structure around it twisted and pulled toward its center. Eventually, in about 4 billion years, it will merge with the Milky Way to form a brand new giant elliptical galaxy, though Andromeda. The Andromeda system is getting closer, unlike most stars in the universe, as all systems are moving away from us. This is because our universe continues to expand at super light speeds under the control of dark energy. Expansion is the relative motion potential of the object you observe. However, in the expanding space of the universe, the light will undergo a magical red shift when we look back. This will appear to be moving away from you faster. When you go to the solar system, you can also see the giant solar system. Under a large mass, the space-time structure around it will occur, curving and constantly flowing towards the center of the sun. This is also why the Earth's orbit is moving farther and farther away from the sun, but subject to the sun's ever-flowing curvature. On a circumferential scale, the Earth will also attract the surrounding space-time network grid and move in its direction closer to the center of the flow. The speed will be stronger, which makes the rocket need a very high speed to fly away from the Earth. A good explanation for this phenomenon is that we are near the Earth. Putting a few apples close to space-time will not only destroy them all, pulling towards the Earth and also gathering towards the center. The phenomenon is tidal action. It is through this that the moon, the space-time grid caused by tidal forces, and the rotation of the Earth, a slight rotation, caused the Earth's oceans to become unstable, interrupted flow. When we throw an apple, that is, even if it does not touch the Earth, it will be rotated by the Earth. The curved space-time grid structure changes its whereabouts, the trajectory and direction. When we come to the interior of the Earth, you will see that the curvature of space-time still divides all objects. The reason why the Earth did not collapse when pushed to the center is because the hot core of the Earth is constantly exerting pressure on the outside. The reason why the Earth's surface continues to expand outward because of the force. The size of the Earth has not increased because the Earth is strong. Gravitational pull causes the surrounding space-time structure to face the Earth. The direction of contraction is Einstein's bending time. The sun will finally face its fate in about 5.1 billion years. Its end comes due to the inability to continuously exert pressure on the outside. If it resists the curvature of the flow, its core will begin to collapse, collapsing to form a deadly white dwarf. But not all stars will end this way if the stars have enough mass to reach the end of its life. Not only will collapse occur, but the outer material will, after being squeezed to the core, it will rebound violently in terrible, supernova explosions while the core of the star continues to collapse. The densest one is finally formed, called a neutron star. It not only stretches the surrounding spacetime to the extreme, the structure may even change the trajectory of light. If it is a more massive star that is exploding, when it explodes it will form a black hole. When it explodes, its gravity will pull space at the speed of light. The light emitted by the structure will expand continuously. The bubble form begins to expand as the growing bubbles and air. When the contraction reaches an equilibrium point, the bubble will stop growing. This is the black hole and the space-time around it. The structure will also accelerate and spin in the black hole event world. A kind of energy layer structure is formed outside this region. The inner space-time structure will be dragged into a super light vortex in it, so that all surrounding matter, and even part of it, the split rays, will be dragged and rotated until they enter into the black hole, and as the starting point of the black hole center makes the structure of space-time infinitely distorted, although mathematically it is connected to the white hole and can go to a parallel universe. But in reality, we can't understand it at all. What exactly happens in the space-time region of singularity like this? So big and powerful that all straight lines point here. Time itself points to the center of the black hole, right here. Not even light can escape a black hole, so leading to the singularity is also when any object passes through the universe's ultimate fate. If you enjoyed this Eureka Science Sauce episode, give us a thumbs up and hit that subscribe button, as it helps us create more diverse and Eureka thought-provoking videos. Thanks for watching.